Disc 13.
The Klein episode was by no means the last time that scientists attempting gene therapy found themselves in hot water with regulators. Tragically, it took the death of a patient in a gene therapy trial to bring home the sobering message. Gene therapy, that complicated cocktail of viruses, growth factors, and patience, is dangerous. But the message was more than that. Because there are so many unknowns in the gene therapy equation, strict oversight of all procedures involving humans is absolutely necessary. Jesse Gelsinger died both because we do not know enough to predict with complete confidence an individual's response to gene therapy, and because scientists took inexcusable shortcuts. In 1999, Gelsinger, an Arizona teenager, heard about an experiment being conducted by James Wilson, director of the Institute for Human Gene Therapy at the University of Pennsylvania. Gelsinger was suffering from ornithine transcarbamylase deficiency, OTC, a hereditary impairment of the liver's ability to process urea, a natural product of protein metabolism. Untreated, the disease can be lethal. And though, like PKU, it can be managed with simple medication and an appropriate diet, OTC does leave its victims particularly vulnerable to other ailments. The 18-year-old Gelsinger had only a mild case, but a childhood brush with death, precipitated by his condition, emboldened him to volunteer in the hope of helping to find a cure for himself and others like him. The Pennsylvania therapy aimed to use an adenovirus, a member of the group that causes the common cold, as the vector of the corrected gene. But a few hours after the viruses, carrying a normal version of the OTC gene, had been injected into his liver, Gelsinger developed a fever. A rampant infection followed, accompanied by blood clots and liver hemorrhaging. 3 days after the injection, Jesse Gelsinger was dead. The teenager's death was a shock not only to his family but to the research community as well. A detailed investigation revealed serious procedural lapses. Most glaring, perhaps, was this. Although 2 patients had shown signs of liver toxicity earlier in the same study, the cases had gone unreported to any regulatory authority and were never disclosed to the volunteers in the study. Had the Gelsingers been informed, Jesse would likely not have been so quick to volunteer, and he might well be alive today. The tragedy dealt a serious blow to the progress of gene therapy. For a time, the FDA halted all such experiments at the university and at several other programs across the country. Bill Frist of Tennessee, the Senate's sole physician, conducted an investigation into reporting procedures in human trials. President Clinton called for improvement in standards for informed consent, championing the right of experimental subjects to be apprised of all potential risks. If any good has come from Jesse Gelsinger's death, it is that federal oversight of human trials has been tightened. The gene therapy community was still reeling from the shockwave caused by Gelsinger's death when heartening news of a success story came from France. The disorder targeted was SCID, SCID, the immune deficiency that condemned David Vetter to life in a bubble. Though bone marrow transplants can effect a cure, the recipient of the first transplant done in 1968 is still healthy today. The success rate is only about 40%, and even successful transplants frequently lead to grim complications, as in Vetter's sad case. In 2000, a team under Alain Fischer at the Necker Hospital in Paris carried out gene therapy on 2 infants who, like David, had been kept in sterile isolation since birth. As with the treatment for ADA, a retrovirus was used to ferry the needed gene into cells extracted from the babies. The cells were then reintroduced. But in a notable innovation, the French group harvested the cells to be modified from the infant's bone marrow. By using the marrow's immune stem cells rather than ordinary T cells found in the blood, the method, if successful, promised to furnish a self-perpetuating genetic fix. When stem cells reproduce, they increase not only their own numbers, but also the numbers of the specialized somatic cells into which they naturally differentiate. Therefore, any T cells produced from altered stem cells would also carry the inserted gene, making the repeated infusions of modified cells unnecessary. And that is exactly what happened. 10 months later, T cells containing a working copy of the missing gene were found in both patients, and their immune systems were performing as well as those of any normal children. Fischer's method has since been applied to other SCID children. After a long and not altogether auspicious start, gene therapy had finally notched an unequivocal success. But the champagne celebration did not last long. In October 2002, doctors found that one of the 2 original patients was suffering from leukemia, a cancer of the bone marrow, in which certain types of cell are overproduced. Though it has not been established for sure that the genetic procedure was responsible, the circumstantial evidence is mighty strong. Gene therapy seems to have cured the baby's SCID, but caused leukemia as a side effect. Side effects have always dogged medicine. Drugs may affect more than just their intended target, or surgical procedures may end up causing complications. Though in many ways a departure from conventional medicine, genetic medicine, we now know, is also subject to the same law of unintended consequences. Fischer's SCID treatment probably inadvertently created new problems in the process of fixing the original one. After all, any treatment requiring the insertion of viral DNA into the DNA of patients' cells is inherently risky, because the foreign DNA may by chance disrupt the functioning of a critical gene. Because typically the cell in which this has occurred will die, such events usually have no impact. But it is possible that the disrupted gene is one whose elimination does not kill the cell, but rather unlocks its capacity to multiply unchecked. The viral insertion can cause cancer. This seems to be what happened.